A very pleasant day to all of you. Ma'am Edita de Jesus and my fellow students. We are Group 5 and we will be presenting the last topic for the midterms. Week 11 Patterns in Species Richness. Just a quick overview about our topic. What is species richness? Species richness refers to the number of species present in a community and is a key measure of biodiversity. Basically, species richness determines the number of the population in a certain habitat or community. It varies widely across different environments due to the factors such as resource availability. If there are lots of resources such as food, mas magta-thrive ang isang population. Another factor is environmental conditions. Dito na papasok yung range of tolerance na natakil natin nung preliminary, which is how a certain species adapt to their environment based on their tolerance that is essential for survival and growth. And species interactions like competition and predation is another factor. These variations follow observable patterns across various tropics. This topic explores the distribution of biodiversity across the Earth's surface. It examines how various environmental, historical, and geographic factors like climate, land area, and habitat complexity interact to determine the total number of species found in a specific region. Upon completion of this topic, you are expected to quantify species richness and diversity, analyze spatially varying factors, evaluate temporally varying factors, explain the impact of habitat area and remoteness, and lastly, to identify and describe gradients of species richness. When we are studying ecology, it is important to understand why species richness varies across different environments. Species richness helps us understand how ecosystems function and how they respond to environmental changes. To better understand this, scientists don't just count species but also use different methods to measure diversity more accurately. For one cannot possibly count the number of species manually, so scientists develop different methods with regards to the certain area that they inhabit. Species richness is affected by many factors. Some of these are spatial factors like climate, location, and availability of resources, which vary from place to place. There are also temporal factors such as seasonal changes or disturbances that affect species richness over time. Another important factor is habitat area and remoteness. Larger habitats usually support more species because they have more space and resources, while isolated or remote areas may have fewer species due to limited movement of organisms. Lastly, patterns like gradients of species richness, including changes across latitude or altitude, shows how biodiversity differs around the world. These patterns help scientists understand the bigger picture of how and why species are distributed the way they are.
Hello everyone, I'm Kathleen Lane PR Panel and today I'm gonna introduce you to our topic which is quantifying species richness and diversity. Ano nga ba ang quantifying species richness and diversity? It means measuring how many species are in place and how evenly their numbers are distributed. Understand the Earth's immense variety of life. Basically, it focuses on figuring out the what, where, and why. By the end of this unit, you should be able to differentiate between species richness, species evenness, and overall species diversity, and also to explain the spatial scales of biodiversity including alpha, beta, and gamma diversity. And as for the first one, which is species richness or the count, it is simply the total number of different species present in a specific community, ecosystem, or region, meaning the distinct species ay yung nasa iisang environment or ecosystem. Example is in the picture, which is a bunch of different flowers present in a environment. And the next one is species evenness or the distribution. It measures the relative abundance of the different species making up the richness of an area, meaning the number of an individual across the different species is balanced. Let's say for example is yung nasa picture, meron siyang different types of flowers, merong apat na cornflower, daisy, dandelion, and apat na azure bluet. Masasabi natin siyang balanced population of flowers kasi there are 4 types of each flowers na nasa isang area na walang ibang flowers ang nagdo-dominate or nagka-crowd. And the last is species diversity or the big picture. It is a comprehensive metric that combines with richness and evenness. Going back, richness is the count and the evenness is yung balance of populations. Example in the picture shown. Community 1 has 4 different types of trees, A, B, C, and D. Each type makes up 25% of the forest. Since the population is balanced, it has a high evenness. While in Community 2, same 4 types of trees, the richness is identical to Community 1. However, 3A dominates the area at 80%, while the others are just 5% to 10%. Means it has a low evenness. Ibig sabihin, Community 1 is more diverse because the ecosystem is balanced.
Hello, my name is Lisandro Santos, and I will be explaining which forest is more diverse. But before we get into that, we have to ask ourselves, how do ecologists measure biodiversity across different spatial scales? Ecologists use 3 primary scales. The first one is alpha diversity, or the local scale. It is the biodiversity within a single specific habitat or local site. It is usually expressed simply as species richness. Next is the beta diversity, or the between site scale. It measures changes or turnover in species composition when you move from one local site to another neighbor site. It tells you how unique or different habitats are from one another. As we can see in the image on the right side, we see that the deer is the variability between the forest and the open meadow. Lastly, is the gamma diversity, or the regional scale. It is the total overall diversity across a vast geographic region or landscape, which includes multiple different habitats. It also encompasses both alpha and beta diversity. Now, ecologists use many tools to compare the diversity of communities. They often calculate indexes of diversity based on species richness and relative abundance. One widely used index is the Shannon Diversity Index, or simply the Shannon Index. It measures biodiversity using species richness and species evenness. In the example below is the Shannon Index formula. Now, what does this mean? Well, the A, B, and C is the species in the community. The H is simply the symbol for Shannon Index. The P is the proportion or relative abundance of each species. And the N is the natural logarithm. Now, if the H value is higher, then it is a higher diversity. If it's lower, then it's lower diversity. Now, to compute the previous example, we have to divide the proportion by 100. In this case, 25 divided by 100 is 0.25. Next, we have to calculate the natural logarithm by taking the proportion and added it to the natural logarithm and compute it. We will have the approximate equation of negative 1.386. Multiply that by the proportion 0.25 and we will have the answer approximately negative 0.347. Multiply that by 4 because we have 4 same values with A, B, C, and D, and we will have the approximate value of 1.386. Do this with community 2 and we will have an approximate equation of 0.708. If we rounded up the values, then for community 1, it is 1.39. And for community 2, it is 0.71. Now, we can confidently say that community 1 has a higher diversity than community 2. What is the main purpose of quantifying species richness and diversity in ecology? It is to objectively measure the variety of life in ecosystems, enabling comparisons across habitats, tracking changes over time, and informing conservation and management decisions.
In conclusion of our topic is evaluating diversity is a cornerstone of ecological research and conservation efforts, which simply counting the total number of different species present, and also to incorporate species evenness to determine how uniformly individuals are distributed.
Hello again. Before I begin, let me formally introduce myself. I am Jackie Daniel M. Alpay, and I will be introducing you to subtopic number 2, spatially varying factors influencing species richness. As I've said before, species richness is the most common measure of biodiversity that represents the total count of different species within a defined area. This highlights that biodiversity distribution is not uniform across the globe, as organisms are organized in inconsistent structures and gradients. By identifying primary spatial drivers, we can understand why certain areas harbor extreme levels of life while other regions remain species poor. By the end of this unit, you should be able to define spatial richness and variation in ecological contexts, identify factors affecting spatial richness, and explain how differences in the environment influence species distribution and diversity. In an ecological context, when we say spatial, it studies how organisms are distributed in space. Spatial heterogeneity is a term used for the non-uniform distribution of elements across an area. It represents the structural complexity of a landscape by combining spatial richness with spatial diversity. Now, what is their difference? Spatial richness refers to the number or diversity of features found in an area. In other fields, it can refer to the variety of resources, land uses, or cultural features present in a place, while spatial variation refers to the differences in characteristics from one place to another. These differences may involve climate, elevation, vegetation, population, or biodiversity. It explains why one area might have a lot of trees while another nearby area is urban. To sum it up, spatial richness is the number of different types of features, while spatial diversity is how those features are arranged.
Today, I will be discussing factors affecting spatial richness. Spatial richness refers to the number of different species present in a specific area. The more species found in a place, the higher its spatial richness. This is an important concept because it helps us understand biodiversity and how ecosystems function. First is climate. Climate includes temperature, rainfall, and sunlight, which are essential for life. These factors determine what organisms can survive in a particular environment. For example, tropical regions like the Philippines or Amazon rainforest are warm and receive a lot of rainfall. Because of this, they support a wide variety of plants, animals, and microorganisms. On the other hand, deserts such as Sahara have very little rainfall, so only specially adapted organisms like cacti and camels can survive there. This shows that favorable climates lead to higher spatial richness, while extreme climates limit biodiversity. Next is habitat diversity. This refers to the variety of habitats found in a certain area. If a place has forests, rivers, mountains, and coastal areas, it can support more species because each habitat provides different living conditions. For instance, a forest can support birds and insects, rivers can support fish and amphibians, and mountains can support unique plant species. A good example in the Philippines is Palawan, which has mangroves, coral reefs, forests, and caves. Because of this wide range of habitats, it is considered one of the most biodiverse areas in the country. So, the more varied the habitats, the more species an area can support.
Next is the soil and nutrient availability. Fertile soils support more plant life, which in turn supports more animals and microorganisms. This is why the Amazon rainforest supports more life as it has a soil and nutrient availability than desert climates, which has little soil and nutrient availability.
Another important factor is water availability. Water is essential for all living organisms. It is used for drinking, reproduction, and many biological processes. Areas near rivers, lakes, or oceans tend to have higher biodiversity because water supports both plant and animal life. On the other hand, places with limited water like deserts have fewer species. So, the more water there is in an area, the more it increases spatial reach. Next is geographic location. This refers to where a place is located on Earth, especially its distance from the equator. Areas near the equator receive more direct sunlight and have more stable climates throughout the year. Because of this, they support more species. For example, tropical countries like the Philippines, Indonesia, and Brazil are known for their high biodiversity. In contrast, areas near the poles are colder and experience extreme seasonal changes, which limits the number of species that can survive. Thus, locations near the equator tend to have higher spatial richness. We also have disturbance and natural events. This includes events like floods, fires, typhoons, and volcanic eruptions. Interestingly, moderate disturbances can actually increase biodiversity. For example, small forest fires can clear old vegetation, allowing new plants to grow and create habitats for new species. However, extreme disturbances such as strong typhoons or volcanic eruptions, like Mayon volcano eruptions, can destroy habitats and reduce species richness. So, disturbance can either increase or decrease biodiversity depending on their intensity. Lastly, we have anthropogenic activities or human activities. Human actions such as urbanization, deforestation, pollution, and agriculture often reduce spatial richness by destroying habitats. For example, cutting down forests for buildings or farm removes the natural homes of many species. However, humans can also have positive impacts. Conservation efforts like protected areas, wildlife sanctuaries, and reforestation programs help restore biodiversity. This means that human activities can both harm and help biodiversity. In conclusion, spatial richness is influenced by several factors including climate, habitat diversity, soil, water, geographic location, natural disturbances, and human activities. Understanding these factors is important because it helps us protect ecosystems and maintain biodiversity, which is essential for life on Earth.
So now, we will tackle the unit 3 of our lesson, which is the quantifying species richness and diversity. But first, what is species richness? So, species richness is classified by the number of species that are present in a certain area. So, ang ini-state lang ng species richness is kung gaano karami ang certain organism or species na present dun sa isang lugar. Na naapektuhan siya or it is greatly affected by the changes that occur over time. So sinasabi dito na species richness can be affected dahil sa mga changes na nangyayari over time. For example is seasonal variation, availability of nutrients, migration, and survival na nakaka-affect sa presence ng organism on a certain environment or habitat. There are also things like long-term climate changes that affects the biodiversity patterns. For example, is flood and fires na nakaka-apekto sa number of contribution to a certain diversity that happens over time. Species richness is not just about the space of that certain community, but it is also how long it is or the time. So in ecology, we look in two time scales, the evolutionary time and the ecological time, in both determine the biological capacity of a habitat. For our learning objectives, by the end of this unit, you should be able to evaluate the impact of seasonal phenology on transient species richness, to quantify richness recovery rates post-disturbance, to assess the extinction depth of fragmented landscape, to analyze the homogenization of richness over time, identify how disturbance like fire, storm, and etc. as a or act as a temporal regulators of biodiversity, and understand the dynamic equilibrium where species arrival and thus reach temporal balance. Now, for our definition of terms. Disturbance. Temporary change in environmental conditions that causes a significant shift in an ecosystem, often by destroying existing biomass and freeing up resources for new growth. Next is species richness, which is I discussed earlier, which is the total number of different species that is present in a certain area or environment. Ano nga ba ang temporally varying factors? Temporally varying factors are the time-dependent environmental and historical processes ranging from a short-term disturbance to a million-year evolutionary cycles that determine the rate at which species are added to or removed from a community, ultimately shaping its total species richness. So, ang ini-state lang nito is temporally varying factors are time-based event that affects or act as a revolving door in an ecosystem. Bakit? Kasi ang temporally varying factors or ito ang nagdedetermine kung ano ba or kung anong species ang papasok at ang lalabas in a certain environment or habitat. These factors range from a quick shakes up or like a sudden forest fire or flood to a slow motion of changes like ice ages or million years of evolution. So it acts as a constant filter over time na nagpa-process sa speed ng species na nag-a-add or remove to a certain community. Kumbaga, ang temporally varying factors ang nag-a-act as a nature schedule na nagde-decide sa species richness, or siya yung nagbibigay ng head counts of different plants and animals na makikita natin sa isang habitat or environment. Now, we will go to types of temporally varying factors. First one is the climatic variability and seasonality. Climate variability refers to short-term natural fluctuation in atmospheric conditions like temperature, precipitation, or over months or seasons or years. So, climate variability is unpredictable weather moods na nangyayari from year to year, such as unusual dry summer or a warm winter. While the seasonality naman represents the expected regular annual cycle of weather changes. The seasonality naman is the masasabi nating predictable calendar. Ina-expect natin na mangyayari or magta-transition from a rainy season to dry season or from winter to spring. Kind of cycle, siya yung cycle ng weathers na ina-expect ng mga tao. Or siya yung nagfa-follow ng a certain regular or repeating loop na nangyayari in a year or in a span of 12 months. These two factors act as a temporally varying factors because binabago nila yung environment over time. Nagsishift sila from season to season na nagde-determine which resources ang available at tumutulong sa magde-decide kung ano bang species ang makakasurvive on that certain habitat in a certain community. We will now proceed to its classification. The first one is temperature and precipitation. Seasonal changes in temperature and rainfall are critical, particularly for ectotherms, with breeding activity usually concentrated in warmer weather periods. So, ang in-state lang naman ito or the temperature and precipitation act as a starting whistle for nature. Because most of the animals or many animals like frogs and insects, hindi sila nakakapag-produce ng kanilang own body heat. So, they wait for the warm and wet part of the year or season of the year to wake up, move around, and have their babies. Then, kapag naman lumamig or nag-dry, usually nagtatago sila or nag-hibernate. For the second classification is the photoperiod. The length of daylight serve as the environmental cue that can directly drive species richness, independent of other weather factors. So, dito naman sa photoperiod, in-state lang niya the amount of daylight in a day. So, even the weather is cold or warm, ang araw is may sinusunod siya na certain schedule. And that schedule, ginagamit siya ng organisms such as ng plants and animals as a clock to know exactly the time to bloom, migrate, or change their fur. Regardless what thermometer says. So, kahit malamig ang panahon or sabihin natin na cloudy or what, basta lumabas yung araw, ginagamit ito ng organisms to bloom and to drive their species richness na independent sa other weather factors. For the third classification is the hydrological cycles. In floodplains, species richness often declines during floods, with the magnitude of this change depending on the whether the system is natural or dammed. So, dito naman is, inaano niya lang kung how water moves. On how water moves. Like, for example, is when a river overflows into a plain in a natural system. So, kapag nangyari yon, a big flood might temporarily wash up some species away, making it harder for them to stay. But, with human intervention, nagbuild ang humans ng dam na nakakapag-change with the natural flow, na it's let's say na permanently change how many different species can live there. With this human build dam, nakakaapekto sila or nakakatulong sila sa natural flow ng tubig and nag-contribute siya sa kung gaano kadami ng species or organisms ang pwedeng manirahan on that certain habitat or environment. Then, when the rain returns or wet season na, nag-switch sila ng places, which is yung lumalabas na yung mga organisms or species na kayang mag-adapt and mag-survive in wet season, and usually yung mga dry season organisms or yung mga hindi ganun makasurvive or makapag-adapt sa wet season na organism ay nagtatago, kaya nagsiswitch places sila. This constant swapping is why the number of species you see changes depending on the month. Ibig sabihin nun is, kung anong species ang nakikita natin in that certain environment is nakadepende kung dry or rainy season ba. Kasi, on that specific season is, yun lang yung organisms or mga species na nakakapag-adapt sa mga changes in that environment or habitat. Now, we will go to disturbance regime. The disturbance regime is the long-term pattern, frequency, and intensity of physical event like fire, flood, or storms that can shape a specific ecosystem over time. So, ang disturbance regime naman is, siya yung disturbance na hindi lang nangyayari just one time. It is a regular cycle of events like flood or fires. Then, kapag tinignan natin kung gaano siya ka-often nangyayari or gaano siya kalakas, we can predict how an ecosystem will change and which species will be tough enough to stay. So the disturbance regime, it is the cycle. It is a cycle na paulit-ulit nangyayari. And makikita or titingnan natin kung gaano kalakas yung impact niya on that certain habitat on environment. Then, kapag naano na natin yung cycle na yon, is mapapredict natin kung gaano ba or ano bang species or anong type of organism will be tough enough to stay and claim that habitat or environment. Now, we will proceed to the disturbance regime classification. The first one is the disturbance frequency and intensity. Moderate intermittent disturbance, for example, fires, floods, and wind throw, often maximize species richness by creating a mosaic of patches and different successional stages. So, the disturbance frequency and intensity, siya yung nag-aano ng perfect balance. If the disturbance like fire or floods happen too often, then the result will be nothing can grow. But if they happened or they never happen or just one or two times in a certain cycle, the dominant species will take over everything, resulting to just the starting over or the others are too old to establish. Then the species richness will be high because there is a spot for everyone to adopt. The next one is the colonization and succession. Disturbance creates an open space for colonization, leading to a dynamic patchwork of species. So, in this classification naman is it talks about when a disturbance like a storm or fire happens, kini-clear out niya yung space na nag-a-act as an invitation for a new species to move on, na nagre-result to a dynamic patchwork when an ecosystem is always changing and updating itself, and it keeps the community diverse and healthy. Dahil nga sa pag-colonize ng another species with that habitat, magkakaroon ng bagong diversity or mga certain things na mangyayari with that habitat or environment.
So now, as we continue, punta naman tayo sa resource availability and productivity. Ano nga ba ito? It defines the input and output of an ecosystem, where availability is the input and productivity is the output. Availability is the supply of essentials in an ecosystem like food, water, and nitrogen, while productivity naman is the rate at which life converts those essentials into growth. So as we can see, there's a graph in here that shows various ecosystems like rainforests and deserts that have different levels of productivity. Example narito is that may mas mataas na productivity yung mga lugar na kung saan may sapat na tubig at araw. In this slide naman, which is part pa rin ng resource availability and productivity, which focuses on the timing and long-term changes of these resources, and dito yung seasonal resource pulses, which implies that resources aren't always steady. Pulses like a sudden bloom of fruit or a salmon run allow different species to survive by eating at different times, a concept known as temporal niche partitioning. Then, nutrient decomposition. Ito naman, it warns us that too much of a good thing can be bad. Constant nitrogen from pollution or fertilizer can actually decrease species richness because of a few fast-growing species that might crowd out the others. Another type is biotic interactions and temporal niche partitioning. Where temporal niche partitioning, ito yung parang scheduling time or oras ng pagkain ng mga animals or species, which is upang maiwasan yung direct competition for food. Other animals eat in day and others as in night, which is we call diurnal and nocturnal. So, and as we can see in the image, it illustrates how human activity disrupts animal behavior. In low human use areas, predators and prey have specific activity patterns, while in high human use areas, species shift their activity to different times of the day to avoid humans, which can lead to increased competition or mismatch as hunting times. In competition, ito yung kakaunti lamang ang resources na maaaring mapagkunan na maaaring mag-lead sa kakaunting species ang maaaring makapag-survive or manatili. Pero kapag naman not moderate disturbance, mas maraming species ang maaaring makapag-survive or magkaroon ng chance na mabuhay ng sabay-sabay. And phenological shifts naman, ito yung mga animals na nag-a-adjust ng kanilang reproduction time upang wala silang makasabay sa mapagkukunan ng pagkain. And now, the last type of temporal varying factors is anthropogenic changes. What is anthropogenic changes? Ito yung mga pagbabago direktang gawa ng mga tao tulad ng pollution, pagpuputol ng puno at climate change. And in the image or infographic, it compares human versus natural causes of change. It highlights human-driven emissions and land use changes. It contrasts this with natural factors like volcanoes or solar cycles, visually emphasizing that current rapid climate shifts are heavily weighted toward human influence. The two biggest human-driven threats to biodiversity is land use changes and climate change. Land use changes implies that urbanization and agriculture are the primary drivers of habitat loss. When we turn a forest into a parking lot or a monoculture farm, species richness always almost drops. And climate change, this alters the water energy dynamics. In polar regions, this looks like melting ice. In arid regions, it looks like extreme desertification. Both make the habitat unstable for the species that evolved there.
Hello everyone, my name is Yelena Estrada and I will introduce our subtopic, which is habitat area and remoteness. The introduction is the equilibrium theory of island biogeography ay isang mahalagang konsepto na nagpapaliwanag kung paano naaapektuhan ang dami ng species sa isang lugar. It developed by Robert MacArthur and Edward Wilson. The theory emphasizes the spatial factors, particularly the habitat area and remoteness. Ayon sa theory, mas maraming species na makikita sa malalaking habitat dahil sa mas mababa ang extinction rate at mas diverse ang environment. Samantala, ang mga lugar na malalayo o isolated ay mas kaunti ang species dahil limitado ang immigration o pagdating ng mga bagong organism. Overall, the species richness ay nakabase sa balance ng immigration at extinction na bumubuo ng isang equilibrium sa ecosystem. The objectives is, by the end of this unit, you should be able to explain the species-area relationship and its mechanism in habitat patches, and also to understand how remoteness affects colonization, extinction, and endemism, and also to identify the relationship between the habitat physical area and its capacity to sustain diverse species in the area effect. And lastly, is to evaluate the impact of geographic isolation and distance from a source population on colonization rates and the distance effect. The definition of this topic is the habitat area ay tumutukoy sa natural na lugar kung saan nakatira ang isang organism, kasama ang biotic at abiotic factors tulad ng pagkain, tirahan, klima, at lupa na tumutulong sa survival nito. Samantala, ang remoteness naman ay tumutukoy sa kung gaano ka-isolated ang isang lugar mula sa tao, kalsada o infrastructure. Dahil dito, mas nagiging maayos ang habitat kasi mas kaunti ang disturbance at mas malawak ang undisturbed spaces.
So area effect is the larger geographic areas that support more species because nagproprovide sila ng mas maraming resources and mas malalaking habitats. And it leads to a larger and more resilient population. So as we can see here in our illustration, it shows how an island or how the size of an island influences biodiversity primarily through the extinction rates. The small island represent the ES. As we can see here, the ES, ito yung merong mataas extinction rate because small island, so maunti lang yung resources nila and smaller yung habitat. And they support smaller populations that are more vulnerable to trans-extinction events. While yung larger islands naman represents the EL, ito naman yung merong mababang extinction rate because they can support larger and more stable populations and offer a wide variety of ecological niches. So, ang outcome nito, the equilibrium outcome is the point where the colonization line intersects the extinction line. Yan, ito yung colonization line, it intersects the extinction line that represents the equilibrium number of species. Because the extinction line for large islands is lower, it intersects the colonization line further to the right. That results in a higher equilibrium number of species, or that represents the SL here below, compared to the small islands. Next is the distance effect. So distance effect is the Next is the distance effect. So distance effect is the distance between a habitat and a source population, katulad na nga ng mainland. And it is primary factor in determining the immigration rates. And as we can see here, again in our illustration, it shows how an island's isolation from a mainland source, or that represents P, yung mainland nagre-represent siya as P, influences biodiversity through immigration rates. So the near islands, ito yung islands na malapit sa mainland. Meron siyang mataas na immigration rates that represent ito siya, yung CN, or it means near. So it is physically easier for organisms like seeds, birds, or insects na ma-reach yung islands na yun. While the remote islands naman, or ito, yung CF, ito naman yung merong mababang immigration rate. CF meaning far, because the distance nag-act siya as a significant barrier to dispersal. And the equilibrium outcome, when assuming an constant extinction rate here, tumaas yung extinction rate niya. Yung intersection point for near islands occurs much further to the right dito sa x-axis natin. This means that islands closer to a source will naturally maintain more species than those that are far away. And now to answer this question, how do habitat area and remoteness influence the species richness? So as what I said earlier, habitat area and remoteness, nakaka-influence nga ito sa species richness because yung larger habitats is nagpro-provide siya ng more resources and more ecological niches and lower extinction rate risk. While yung remoteness naman or yung isolation, nababawasan nito yung species immigration since fewer organisms can reach distant habitat patches, which may result in lower species richness. So what I've mentioned earlier nga yung area effect and distance effect
Those are the two primary components of the equilibrium model. And the equilibrium theory of island biogeography proposed by MacArthur and Wilson explains that larger, less isolated islands support more species by balancing these rates. And basically, yung illustration ng island equilibrium model explores how geographic factors influence the number of species found on an island. So yun nga, yung area effect, pinapakita dito na yung larger islands generally has more species because meron sila na mababang extinction rates than smaller land masses. While the distance effect, pinapakita dito that islands located closer to the mainland nagpapasa sila ng higher biodiversity due to more frequent immigration and colonization. And by the intersection of colonization and extinction rates, nabivisualize dito kung paano yung equilibrium ng species richness is na-maintained. And ang most diverse environments are typically those that are both large in size and geographically accessible.
The conclusion of our topic is habitat area and remoteness are important factors that influence species richness. Mas malalaking habitat ang kayang mag-support ng mas maraming species dahil mas maraming resources at mas mababang chance ang extinction. Meanwhile, ang mga isolated o malalayong lugar ay mas kaunti ang species dahil limitado ang immigration. Kaya, understanding these factors helps explain biodiversity patterns at importante ito para sa effective conservation planning.
So, today we will be tackling about the gradient of species richness. Now, the goals of this lesson is to learn about the gradient of species richness and the key factors that affect the distribution of species, while analyzing the various concepts and the hypothesis that explains the effect of gradient of species richness in the ecosystem. And lastly, to explain the ecological significance of species richness gradients. Now, a short introduction about gradient of species richness is that in 1850s, both Charles Darwin and Alfred Wallace pointed out that plant and animal life was generally more abundant and diverse in tropics compared to other parts of the globe. Since that, many researchers have confirmed this observation. Now, moving on, what is gradient of species richness? Now, what is gradient of species richness? Gradient of species richness refers to the gradual change in the number of species across a geographic or environmental gradients such as latitude, altitude, depth, and temperature. The latitudinal gradient in species richness is such that most surviving eukaryote, perhaps also prokaryotes, are found in the tropics. Now, how general is gradient in species richness? The latitudinal gradient in species richness occurs in terrestrial freshwater and marine realms. It is repeated in both local and regional assemblages and has been documented in a wide range of taxonomic groups including viruses, bacteria, plants, arthropods, and vertebrates. While there are exceptions to these, because these primarily involve relatively species-poor taxonomic groups, that said, for most groups, the gradient of increasing richness toward lower latitudes is only continuous when viewed at coarse spatial resolutions. Now, gradient of species richness is the predictable pattern of change in the number of different species as you move from one place to another, such as from the cold poles to the warm tropics. Another example of this is when you look at the species present atop a mountain and the species present in the lower part of the mountain. So there are several key factors that can affect to the latitudinal gradient of species richness. One of such is evolutionary history, which refers to how long the communities have existed and evolved in a place. So in this, tropical regions are older and more stable than temperate or polar regions. That is because temperate and polar areas were often reset by disturbances such as the ice ages or glaciers. Because tropical systems were not restarted as often, Species had more time for speciation, or the formation of new species in that area. So another example of this is climate. Climate also influences how many species can live in an area. There are two main climatic factors such as sunlight and precipitation. This occurs at high levels in tropical regions which increase plant growth and productivity, provides more energy and resources, and supports more species and ecological niches. Moving on to evapotranspiration, which is the loss of water from soil and plants through evaporation and transpiration. It depends on three main factors such as sunlight, temperature, and water availability. Evapotranspiration is generally higher in hotter regions with abundant rainfall, while it is lower in areas with low temperature or little precipitation. Scientists use evapotranspiration rates to combine these climate factors when studying ecosystems. Scientists use evapotranspiration rates to combine these climate factors when studying ecosystems. Species richness of plants and animals correlate with evapotranspiration, wherein in areas with higher evapotranspiration generally supports more species. Moving on to another topic is the area effects. The species area relationship states that larger geographic areas contain more species. Reasons for this pattern is that larger areas have generally greater habitat diversity with more microhabitats available for different organisms. Scientists test this pattern by comparing species numbers in different regions. Examples of such is in the Sunda Islands, bird species increase as island size increase. Although the rate of increase varies, the overall pattern remains consistent. The species area relationship has been observed in these examples, the ant diversity in New Guinea and the plant species on islands of different sizes. Now, moving on to the last part of the discussion, the theories and the hypotheses, where uh, there are two main hypotheses being presented. The stability or time hypothesis, which states that tropical areas have led to a stable climate for millions of years and were not heavily affected by events like ice ages. Because these ecosystems are not repeatedly disrupted, species had more time to evolve and accumulate, resulting to a greater biodiversity. And the second one is the energy and productivity hypothesis, where it explains the regions near the equator that receive more sunlight and rainfall throughout the year. The increase in plant productivity and creates more food and resources in the ecosystem, with more available energy and resources and specialized leading to higher species richness.